Okay, here's another example of using a boundary surfaces that I would like you to practice. So sketches are given. It's a bunch of sketches that are already provided, and you're more than welcome to take a look at the relationship. Now, let's start by saving this into our exercises. I call it the catheter handle. And since it's already given, the sketches, we are going to start by going to the boundary surfaces. So direction 1 would be this profile into this profile, and all the way to the last one. And all other sketches like along this would be defined as direction 2, which would be this one and this one and this one, and finally this one. Now let's create the entire boundary here. So hit OK. We have the surfaces. I'm going to hide all the surfaces here, or we can keep it at this moment for just sake of argument to be used. But essentially, I can hide it if you want it. So let's hide it. We are going to bring it back if you want it. Now, there is another sketch at the end of it, sketch 9, that I would like to create a revolve around it. So it's I'm going to select that, go to the revolving sketch, and the axis of revolution would be this one. Just added this one to the end. And about top of it, we have like these sketches, 10 and 11. And let's make the 10 and 11 visible for a second. Now I'm going to close this sketch with this as a constraint profile, and this cannot happen on the boundary surface because in direction 1 there is no direction 1 and direction 2. The best case for this is what we have tried that, and it is field surfaces. But instead of previous example like in most computer to have give them all the boundary, I'm going to give them a pouch boundary, and then this would be the constraint curve, which I'm going to close this, and this would be the constraint curve. Select this field, and let's select these two sketches. Now it's going to hit OK and going to nice and smooth, closing that. And I'm going to select these two and hide it. Now that this has been defined, I can knit all the surfaces together. So I'm going to go to knit surfaces, select them all. There's no gap control between them, so that generates a single surface. And there's a good option that I would like to create here is I don't want it to thicken, because if I see from, let's say, from this boundary, probably is easier to see. So this is the surface. I keep it this one. I don't want it to thicken, because thicken is going to add the thickness in either direction of this surface. But I wanted to create a solid form with this surface define the outer boundary of that solid. It's different than the thickening, which only creates a solid body with the surface in one of the layers and add the thickness in either direction. So if I'm going back to the surface knit, when I was surfacing this, there is a option that it says create solid. Now, if I say create solid and merge all the entities together, then that would be a solid. You see that there is a difference between this one and the thicken command. Now, the surface that we have defined up until this point would define the outer geometry of this solid body. And now it's fully defined. Now, let's say I wanted to create a hollow off of it. Let's say I have this one, I keep it in this cross section for sake of argument. If I wanted to make this one hollow, I can go and select a shell command. But this was the only thing. I'm not going to practice shell because essentially that's similar to the outcome of the thicken, so there's no value into that. But yeah, so there's a difference between the shell and thicken. The thicken is going to create more into that too for that one. So here's your solid body. Let's save it and close the file.